Applications for color stones. The GemmoSphere has many applications for color stones. In many cases, their UV visibility spectra are diagnostic for the correct classification. In some others, they provide for useful information about possible treatments and the identification of synthetics. Besides an extensive spectral library, the software includes several specific applications which we will briefly introduce in this video. Let's test this blue stone. Press the Autoscan button. The acquisition process will start with the pre-scan, dark scan, and source scan steps, which will be required only one time. Those data, in fact, will be stored by the software to be used for the next stones we will test or until we decide to change the scanning parameters. After inserting the gem inside the integrating sphere, we can continue with the procedure. The unit will now run again the three aforementioned scans with the stone in place, and in few moments we will obtain the absorption spectrum of our gem. Being the integration time directly dependent by the tone and saturation of the color, this process may vary in time from few seconds to maximum a couple of minutes. At the end of the procedure, the spectrum will be displayed and we can search for a correspondence in the database. The auto-search function is labeled as experimental because UV near spectra are affected by so many variables that their features could not be always perfectly consistent. In this case, we had a clear match with the spectrum of a blue sapphire. The almost 500 spectra of the library can be browsed either by name or by group. By clicking Show All in the group window, the entire library will be displayed in alphabetical order, and if we scroll on the names, spectra will appear on the display. By adding a keyword in the filter window, we can narrow down our search. Spectra can be even browsed by group. As an example, like for diamonds, for sapphires we did set up groups based on their color. Let's have a look at the blue and green. Here you have the list of a blue and green sapphire spectra, among them even the sample which was found by the software as the closest match to our stone. In this window there are several useful applications. Back to the spectrum of our blue sapphire. The first application will display the position of the absorption peaks and bands caused by chromophores in blue sapphire. The second one will display a metamorphic sapphire spectrum and its specific features in details. It seems the origin of our sapphire is indeed metamorphic. Let's see how a magmatic sapphire spectrum looks like by activating the specific application. As you can see, the main difference is about this broad absorption band caused by ion charge transfer. The last application of the menu shows the very specific spectrum of a cobalt glass-filled sapphire, displaying the diagnostic peaks related to cobalt. This is the spectrum of an emerald. In the emerald group, we can activate the application of Colombian emerald spectrum to verify if we have matching features. Besides overlapping the actual spectrum of a Colombian emerald, the software will report important details. In red color, two diagnostic elements missing in the Colombian emerald spectrum, both related to the presence of iron, and both present in the emeralds we just tested. We now can conclude our stone is not from Colombia, even if, in order to speculate about its country of origin, far more indicators need to be collected by other techniques. By the way, this is an Ethiopian Shakiso emerald. This is the spectrum of a tourmaline. Cuprian tourmaline, especially if they exhibit a nice and saturated neon blue color, are very rare and at the moment among the highest valued stones. Only a tiny amount of copper impurity separates an indigolite from what is now well known as a Paraiba tourmaline. In the tourmaline group window, there is an application featuring the chromophores. As you can see, our stone indeed includes copper among the impurities, and hence can be classified as Paraiba. We can browse the spectrum of an indigo light from the library to spot for the differences. The GemmoSphere software includes other applications useful, for example, to help in the identification of synthetic aquamarine, of jade types, or to spot for chromium in topaz. The GemmoSphere can operate in reflectance mode for opaque stones. This optional accessory has to be inserted at the bottom of the integrating sphere before starting the scanning process. The hole on top has the size of the collimated beam. When requested by the pop-up window, the stone should be placed on top of the accessory, covering the hole. The spectrometer will collect the light reflected by this portion of the stone and produce its reflectance spectrum. With the GemmoSphere, it is possible to analyze even-mounted gems if the piece can fit inside the sphere and the stone can touch the surface of the collimator's end. Usually metals do not cause any issue. In pieces including other colored gems, though, it could be possible to have slight interferences in the spectrum. We are running now the unit in real time to show the effectiveness of the technique. As you can see here, the mounting did not cause any problem for the collection of the emerald spectrum. Some of our clients became creative when it comes to testing mounted goods. Here you can see the quick spectrum collection of an emerald bead from a very long strand which was too big to be fit inside the integrating sphere. Although the spectrum is not perfect, it was good enough to confirm other analyses performed by Peters Brangoulis about the Colombian origin of the emerald beads.
Thank you for watching this video. For more information about our spectrometers, please visit our website. And if you have any question, please don't hesitate to contact us at info@gemmoraman.com.